Hello everyone, today we will study the thermal expansion. Thermal expansion in different materials like solid, liquid and gas. In case of solid, when the lid of a bottle or a box, it is sometime we feel very difficult to unscrew it or open it. But when we provide heat to it or provide some temperature, then we can see that we can unscrew it easily. In case of liquid, like keeping mercury in a thermometer, when we give heat to it, the level of mercury start rising, so there is increase in the dimension of liquid when we provide heat or temperature to it. In case of gases, we keep a balloon in which air is filled. When we keep it in a cold water, then the size of it start decreasing, and when we keep it in hot water, then the expansion of balloon starts. So in solid, liquid and gases, there is change in the dimensions when we provide heat or temperature to it. So this is thermal expansion. So now we can write the definition of it. The increase in dimension of a body due to increase in temperature. The thermal expansion is of three types. First one is linear expansion. In linear expansion, we take a rod of length L, and with the heat provided, there is change in the length of it. Second one is area expansion. When we provide or when we change the temperature of this body, then there is change in length and height. Means it is two-dimension body, so there will be change in two dimension. Now volumetric expansion. Now we take a cube. When we change the temperature of this three-dimension body, there is change in its dimensions. And the change is in length, height and depth. This is three-dimension body, so there will be change in three dimensions. Now we will study linear expansion briefly. So linear expansion. In linear expansion, if the substance is in the form of a long rod, then fractional change It means that is delta L upon L, change in length upon original length. This will be directly proportional to delta T, means change in temperature. So we can write it change in length upon length, original length, directly proportional to change in temperature. When we remove this proportional sign, delta L upon L is equal to alpha delta T. Here alpha is thermal coefficient of linear expansion, and the definition of it here. Alpha L, the definition of or thermal coefficient of linear expansion is extension in one meter length when temperature increased by 1 degree Celsius. What it means? It means we take a rod in case of linear expansion whose length is 1 meter. 1 meter. When we provide 1 degree Celsius temperature, change in temperature to it, so whatsoever there is increase in length, that will be called thermal coefficient of linear expansion, or that will be equal to alpha L. So we can write alpha delta L by L delta T. We have taken it from previous expression. From here we have find the alpha. Now change in length. Change in length we can write LT, length at temperature T, minus LO, length at the time of original or origin. So this is delta L. Now alpha can be written as delta, and we can write it LT minus LO. This L is original length, delta T. So this will be the value of thermal coefficient of linear expansion. From here we can find LT, that will be equal to alpha L delta T plus L naught plus L naught. From here we can take alpha naught L naught common, 1 plus alpha, so it will be alpha 1 plus alpha delta T. So change in length after temperature T will be equal to L naught 1 plus alpha delta T. Same will be the case of in case of aerial and volumetric expansion. So in case of aerial expansion, change in area after providing change in temperature T, it will be equal to A naught 1 plus beta delta T. Here beta is thermal coefficient of areal expansion. In this case, beta will be when we provide temperature to 1 meter square body, and when provided change in temperature of 1 degree Celsius to 1 meter square body, then it will be thermal coefficient of areal expansion. Now volume expansion or volumetric expansion. It will be equal to, as similar as linear expansion, it will be equal to V naught 1 plus gamma delta T, and this gamma is equal to thermal coefficient of volumetric expansion. And the definition of gamma will be, we will take 1 cubic meter body and we will provide change in temperature of 1 degree Celsius, and the change in the dimension of a cube in a three-dimensional body, that will be equal to thermal coefficient, that will be the definition of thermal coefficient of volumetric expansion. That's all for this topic.